All right, so Unit 10, this is Understanding Area. This is 11.1 in your books. And let's get right to the objectives. You will understand the concept of area, which I'm sure many of you think you do already, so that's good. But keep in mind that we're going to be using some of the stuff we've learned from previous units. Obviously, no proofs or anything like that, but as far as some of the other stuff we've learned, Pythagorean theorem and whatnot, that's going to come into play here too. And to be able to find the areas of rectangles and squares. Pretty straightforward for this one. And use the basic properties of area. All right, so let's start with the concept of area. When we measure lengths of line segments, we use standard measures like inches, miles, centimeters, whatever. Those are called linear units because they measure the length of a line, basically. When we measure square units, those are called square inches, square yards, square miles, because we're measuring the area like inside of something, so to speak, not the perimeter. All right, so let's get right to areas of rectangles and squares. We'll start off with a postulate. The area of a rectangle is equal to the product of the base and the height for that base. Now, you probably are used to length times width. We're going to switch it to base times height. Okay, so area of a rectangle equals base times height. Okay, and B is the length of a base, and H is the height. Okay, in a square, base and the height are equal, so we can use the following formula, which is Theorem 99. The area of a square is equal to the square of a side. So basically, you take one side of the square and square it like that, and that'll give you the area of a square. Simple enough. Okay, and the length of a side is S. All right, so let's start with some basic properties of area. We can make three assumptions about area. Postulate here, every closed region has an area. So if it's enclosed like a rectangle, circle, triangle, doesn't matter what the shape is, it has an area. Okay, another postulate, if two closed figures are congruent, then their areas are equal. That makes sense, right? If I have two triangles that are congruent, meaning they have the same side measures, angle measures, whatnot, then their areas should be equal as well. Okay, so like here, even though I've got this kind of odd shaped, polygon here, if I said that those two were congruent, then their areas would also be congruent. So if ABCDEF was congruent to PQRSTU, then the area of region 1 would be equal to the area of region 2. All right. The third assumption is that if two closed regions intersect only along a common boundary, so meaning they intersect right at a line, okay, and the full length of that line is taken up by both, there's no overlap or anything like that, then the area of their union is equal to the sum of their individual areas. So basically, if I took it and separated it, and I found the area of this, and then the area of this, that those two together would have the same area as those two separately, but added together, if that makes sense. So far, you're probably like, I can't believe we're wasting a video on this. This is so easy. All right, so example 1. Let's find the area of a square with a diagonal of 38. See? Okay, now remember what we know about squares. 1, their area is found by one of the sides squared. We need to find the length of that side. So, it's a square, which means the diagonals form a 45, 45, 90 triangle. So this is 45, this is 45, and this is 90. Okay? Which means that these measurements, this 38 is the equivalent of x root 2, and we would need to find those. So that means that each side is 19 root 2. How did I figure that out? Well, if this, let's say we have 19 root 2 here. That's x, okay? And I have to take and multiply that by another root 2. Those two root 2's will become just a 2, and 19 times 2 is 38. So you're going to have to remember some of your triangle ratios or do some trig. Be easy to remember the ratios, so trust me. All right, so each side is 19 square root of 2. And since area of a square is a length of a side squared, we take 19 squared times the square root of 2 and square the entire thing. Okay? Not just part of it, the entire thing. Which means it's 19 squared and square root of 2 squared. So 19 squared is 361. The square root of 2 squared is just 2. 361 times 2 equals 722. So that would be the area of this square. All right. And now one thing I want to make mention of is make sure you're writing down these examples. Okay, I don't put these in here just for the heck of it. These are based off of test questions. The majority of them are. So please make sure you're doing them and trying to understand each step. If you don't understand it, ask questions. All right, second example. I'll forget all this for a minute here. Let's cross all that out. All right. Area of a rectangle has a length of 32. Okay, and the area is 768 square inches. So we need to find the length of the diagonal of the rectangle. It's not as easy as we thought. So since the area of a rectangle equals the base times the height, we need to find the length of this side here. So we could say 768 equals the base. We're going to make 32 the base times the height. So to find the height, all we need to do is divide 768 by 32, which means that the height is 24. Okay? So this would be 24. Now how do we find the length of the diagonal? Pythagorean theorem. Okay? We could do 24 squared plus 32 squared equals c squared. I can clear all that up. And which means that c squared equals 1600, so c itself is 40. Okay, because remember, if c squared is 1600, we take the square root of both sides to get 40. So again, another potential problem that you would see on a test. So if you don't understand it, please ask questions. All right, coming up, we're going to be doing areas of parallelograms and triangles. So if you haven't figured it out by now, pretty much every section we're going to be working with a different shape. So if you get lost on any of them, it's okay, but you need to let me know and ask questions. We're going to move through this unit a little bit slower than normal since we've got plenty of time. Okay? Have a good one.